Hello and welcome to this webinar by Changepond Technologies on machine learning. In this session, we will introduce you to the world of machine learning and its associated concepts, walk you through the various aspects of a sample ML workflow, and also explain how we helped one of our customers incorporate machine learning into their business process and the benefits they saw as a result of it.
Machine learning is an idea to learn from examples and experience without being explicitly programmed. Instead of writing code, you feed data to the generic algorithm and it builds logic based on the data given. All computer systems take an input dataset, do some processing on the data, and provide an output. Since input data is always diverse, the algorithm or the model in our system has to be explicitly programmed for every scenario so that the system provides the desired output. In machine learning, we want to make our system smarter such that we don't have to explicitly program for every scenario. Instead, our end goal is that given any input data in the future, our system should be accurately predict the expected output. Machine learning can be broadly classified into supervised learning and unsupervised learning. Supervised learning is where you have input variable and an output variable, and you use an algorithm to learn the mapping function from the input to the output. For example, temperature and humidity as input variables, we want to predict the probability of rain. Unsupervised learning is where you only have input data and no corresponding output data. Customer segmentation is an example for unsupervised learning. Before we go into the deeper concepts of machine learning, such as data cleansing, modeling, and algorithms, let me introduce the concept of features. What is a feature? A feature is an attribute or property shared by all of the independent units on which analysis or prediction is to be done. Let us take an example of a house. When you want to sell a house, what are the factors which will determine its price? The floor area in square feet, number of bedrooms, number of bathrooms, the style of roofing, whether it has a garage or not. These are the features of a house. Later in this presentation, we will examine features in more detail and why it is important in machine learning. Now let's dive a bit deeper into machine learning. We will talk about a sample workflow for machine learning. Machine learning has basically two steps: training the model and generating predictions using it. Input data has different variables and features. We will select relevant features from it to create the training dataset. The training process involves providing an ML algorithm with training data to learn from. Once a model is trained, we will use it for predictions. The type of ML algorithm you select to build your prediction model will depend on the type of variable you are trying to predict. In machine learning, the output variable is also called the target variable. There are two types of target variables in machine learning. One is continuous and one is categorical. If the target variable you are trying to predict is categorical, then we can use classification algorithms. For example, given some data about a tumor, can you predict whether it is malignant or benign? In this case, there are only two possible outcomes. If the target variable you are trying to predict is continuous, then we can use regression algorithms. For example, given the size and number of bedrooms of a house, can we predict its selling price? In this case, price is a continuous value. The inner workings of ML algorithms is beyond the scope of this webinar, but we will try to give an overview of the ones we have used as part of our projects. There are various types of problems that can be solved using machine learning. In this webinar, we will talk about a use case that we solved using machine learning for one of our clients. We will also talk about classification techniques and how we used it in solving a business problem. Let me give you an overview of the business problem. Our client is one of the largest utility service providers who takes care of network management of telecom companies in UK. They carry out work such as installation, erection and maintenance of cables, trenching and installation of ducts, heavy cable recovery, etc. They also provide a broad range of communication support services to telecom operators as well as to large enterprises and public sector agencies in the UK. On an average, they process more than 1,000 work orders per day. The works include laying cables, giving connections to customers, etc. To lay cables, it might be required to dig up the highways and roads. But before doing such works, they need to get permission from UK's Highway Authority. They have to inform them when, where, and how long the works will be conducted. After completing the work, roads must be reinstated to their previous state. If the reinstatement is not done properly, then the company will have to pay penalty to the highway authority. Prolonged occupation of highways, not cleaning the work site properly, etc. will also lead to penalties. Our client paid penalties in the region of £2 million in the past year. Reducing the incurred penalties became a high priority to the client. After analyzing the problem, we found that this can be achieved by predicting the defects in advance and giving a heads up to the subcontractors who are working on those work orders. Here, our task was to predict whether a work order will end up with a defect or not. This is a typical binary classification problem with two outcomes, like predicting whether heads or tail will occur with the flip of a coin. To solve this problem, we made use of the historical data in our database. 4 years of order execution data was used for modeling. First step in model building was data preparation, where we collect and get the data in a useful format for a model to digest and learn from. First step in model building was data preparation, where we collect and get the data in a useful format for a model to learn from. It involves cleaning, selecting relevant features from the data, and create new features from the data if possible. The data cleaning process involves replacing missing values, removing outliers, and removing irrelevant variables. In this case, we removed columns containing names of the clerks who processed work orders, the comments written by them, etc. Our initial data set had around 110 columns, and after the cleaning process, we were left with 33 columns which were relevant to the problem in our hand. Next step was feature engineering. With our business knowledge and some key inputs from the client, we were able to create some new features from the existing data which helped us to improve prediction accuracy significantly. For example, a work order contains location coordinates at which the work has to be carried out. On an average, a work order contains 3 pairs of location coordinates. In some cases, it could be more than 20. One interesting thing we found was as the number of location coordinates increases, the probability of occurrence of defects also increased. We created a new feature named number of locations to incorporate this information. After data cleaning, feature selection and feature engineering part, we moved into the modeling process. Since it was a binary classification problem, we started with logistic regression algorithm, which is one of the most basic binary classification algorithm. Logistic regression model helped us to identify the significant variables or the variables which influence the occurrence of defects, which in turn helped us in discarding less important variables in further models. Then we moved to tree-based models, decision tree and random forest models. They give better results than the logistic regression model. Our final model used in production was a random forest model, which was able to predict the occurrence of defects with an accuracy close to 90%. We also tried support vector machines for modeling, but the accuracy obtained was less than the random forest model. The reason could be the fact that in the dataset most of the variables were categorical ones. Tree-based models tend to perform well in such cases. The technology stack we used for this process consisted of 4 main areas: data sources, data processing and storage, analytical modeling, and algorithms and visualization. The data source in this case was the work order management system used by the client, and the data was in a structured format. Data was extracted from the SQL database, and R language was used for cleaning, feature engineering, and modeling purpose. And finally, we visualized the results using Shiny apps. Now, let's talk a bit about the implementation cycle. It starts with pulling the data from the work order management system, followed by data cleansing, which takes almost 70% of the total time. Then the feature engineering, followed by the modeling part. Some of the features we created helped a lot in improving the prediction accuracy. In the model training phase, we tried different algorithms with different combinations of features to get the best possible results. Model validation was the next step, and then finally the model was deployed using a Shiny app. The final step, that is the tuning and updating, is an ongoing process which has to be done periodically. What benefits did the client see after using an ML model for predicting penalties? While explaining the business problem, we talked about the amount of penalties the client had to pay per year. It was about 2 million pounds. With the new prediction model in place, we were able to bring it below 1 million pounds. It also helped in reducing the number of work orders executed with penalties and thereby improving the execution performance of subcontractors. It also reduced the number of repeat work order executions by 30%. Okay, now we are coming to the end of the webinar, and let's answer a couple of questions from the viewers. The first question is, when do you go for a machine learning based solution to a problem? Well, if a problem cannot be solved using a classical programming method, then we will explore whether it can be solved using machine learning. For this, we have to check two factors. First, we do an exploratory data analysis to find out whether there are any underlying patterns in the data. If such patterns exist, then it could be solved using machine learning. But we have to make sure that there is enough data available to build a machine learning model and train them. So if the data set for a particular problem is large enough, has identifiable patterns, and the problem cannot be solved using classical programming techniques, then it is suitable candidate for machine learning. The next question is, what are the types of problems that can be solved using machine learning? Well, the type of problems can be broadly classified into four. The first one is a regression problem where we try to predict a value which is continuous. For example, the price of a real estate property. The second type is a classification problem where we try to predict a categorical variable. For example, predicting whether a customer will continue with our brand or leave it. And the third type is an association problem where we try to find out similarity of items. Market basket analysis is a good example for this. And the fourth type is optimization problems where we try to maximize the profits or minimize the cost. Thank you for showing interest and participating in this webinar session. We hope this session has helped you to understand how machine learning works and how it can be used to solve business problems.